first one. Where does the translation point shift to? Where do we start?
-2, 0.
All right, everybody plot a point at -2, 0, please. Okay, now on your test Friday, all the functions we've studied, absolute value, cubes, squares, cubed root, square root, they're all going to be mixed up. So, what do you do? Well, you look at what it tells you to do. This says, I'm a square root function. Take square roots. So what are numbers that we can take the square root of? 1. The square root of 1 is? 1. What's the next number we can take the square root of?
4.
4. What's the square root of 4?
2.
2. If we had space,
It's
9.
and then 3.
The square root of 9 is 3. So these are our moves from this translation point. So I go over 1, up 1, go back to the translation point. Go over 4, up 2, go over 9, up 3. So all those moves happen from the translation point. And then you draw in your graph. Let me see it. That phone has to go away or I can't see it. Okay, so now let's take this graph and answer these questions. The first one's kind of silly. It says, where does the function equal -1? Well, let me draw in my little line at -1. And let's talk about where it equals -1. Does it ever touch this line?
No.
No. So you can say never, no solution. Okay, the next one, where is it less than or equal to 2? So using a graph, you kind of think about this line up here at +2. Where is that function less than or equal to 2? From here to there. From -2 to +2. Now, why do I get to use a bracket on this end?
Because it has an equal to part.
Very good, very good. Okay, so you try graphing this one, and then we'll answer these questions together. Let me know if you need help graphing. If you don't know how to graph a square root, let me help you now, okay?
Sound like me. Okay, maybe some other weekend. Exactly.
Okay, so on this one, we're going to start off at -1, -3. Now, because of this 2, we're going to take and double these moves. So we go over 1 up 2, over 4 up 4, over 9 up 6. And there's our graph.
What numbers do we use to plot again?
Okay, we take 1, 4, and 9 because it's a square root function. So the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. But because of the 2 out in front, we have to multiply this part by 2. I got these backwards. This one should have been 1 and this one should have been -1. Yay.
So when we
Throw a
graph
negative
it-
right here, guys. Correct this one for me. Make this one -1.
Which one, the first one or?
The second one. Go ahead and make it -1.
This will be.
Yeah.
So when we graph it, it's.
Yeah.
I thought it was up 1 over 2. So is it up 2 over 1?
This is always the left and right, and this is always your up and down.
Okay. Draw like
Okay, so if this were -1, then where is this equal to -1 when x is 0? So this is the y value. And what is the x value that goes with that? So when the y is -1, what is the x? 0.
Wait. Miss Willoughby, now I'm confused about your graph. I'm so confused. Okay, that's the first one, and then where's the 2, 4?
It's
Or
4,
without?
4. Over 4, up 4. I went up 3. Oh, that's why it did work.
Yeah.
I have a really hard time counting on this graph. Over 1, 2, 3, 4, up 1, 2, 3. Ah! It would have worked. Really pretty. So we could have done where it equals 1. It equals 1 where x is 2.
So should we just do 1?
You can just leave the other one. It's fine. Okay, where is it less than or equal to -1? From here to here. That's where it's less than or equal to -1. So, from an x value of -1 to an x value of 0. we got to use the bracket around the 0 because of the equal to. Alright, now this last one is not a square root. It is a cubed root. So we have to pick numbers that we can take the cubed root of. Like -8 is -2. -1 is -1. +1 is +1. +8 is +2. So because it's a cubed root, we have to pick numbers we can take the cubed root of. Okay? So from this, drop it down 4. We would go left 8 and down 2 if we didn't have this right here. What does that right there do? It flips it. So we multiply all these by -2. And then, so we're going to go left 8. And instead of down 2, we're going to go up 4. Because we have to multiply it by -2, which you can't see. Let's see if I can change this color. There we go. No. I've changed too many colors. Alright, so we're multiplying all those by -2. So we went left 8, up 4. So we would go left 1, up 2. Right 1 and down 2. And right 8 and down 4. Sure, just leave the door cracked. Alright, so where's the function equal to -8? Right here. That's -8. What is the x value right here? It's not negative, but +8. +8. Okay, this one. Where is x greater than or equal to -6? Okay, so greater than or equal to is over here.
So it'd be greater infinity.
Ooh,
Wait, isn't it only greater than -6?
ooh, yeah. It is greater than, thank you. So it's -infinity to what is this x value? 1. And because there's no equal to, do I get to include it?
No.
No.
Wait, that's greater than I thought, so it's other.
Greater than -6 means
It's
above
before the
-6.
line.
Yeah. Yeah. Okay. So the graphing is not as critical as it being able to solve it. So that's why we just have 3 graphing and then we have a slew of solving. So let's do solving now. Okay, so our rules that we've done for everything still work. We're going to isolate. First, we're going to isolate the radical. Okay? And then we're going to look, is it a square root or is it a cubed root?
Square.
So if we start off with a square root, we're going to square both sides. If we start off with a cubed root, we're going to cube both sides. And then we solve what's left. So these same steps work for almost every single problem we've done. Isolate is our first thing. So on number 7, what do we need to move so that we can isolate the radical? The radical's by itself. The 4 needs to go. So we subtract 4. Now with a square root, can a square root ever equal a negative? No. But this one equals a positive, so we're still good. If we got to this point where we just had the radical and it equaled a negative number, then there'd be no solution. All right, so how do we undo a square root? Square both sides. That's right. So here we get x minus 3 equals 100. And then we just add 3 to both sides and we're all done. So x equals 103.
After you got it by itself, you didn't have to, and you got to move the radical, you didn't have to set it equal to negatives.
You don't own these. These are easier. Alright, so on number 8, what do we have to do to isolate the radical? Divide by 6. So now I have x plus 10 equals 2. So this is doable. It's a radical equal to a square root equal to a positive, so we can do it. So how do I undo the square root?
Square.
You square both sides. Okay, now we do get a negative answer when we move the 10, but that's okay. Because if I were to do a check step here, I got x equals negative 6. If I were to plug that negative 6 back in, the first thing I do is add 10 to it. So it becomes positive. It becomes 4, so I'm good. Okay? I want you to try through number 12 now. I want you to go through number 12 and stop after number 12. If you're not sure what to do, I want you to ask me questions, please. Okay, so on the number 9, all we have to do is move the 6 over. And when we do, it becomes a positive 4. So we just add 6. And so we get the square root of x minus 5 equals 4. And then we square both sides. So we get x minus 5 equals 16. And then the final step is to add 5 to both sides. So our answer is x equals 21. Any questions about number 9? All right, number 10. We're just going to add the 2. And so we get x minus 9, the square root of, equals 5. We square both sides. There you go. And we get x minus 9 equals 25. And then you add 9 to both sides. And we get that the answer is x equals 34. Number 11 has a little more work to it. We subtract the 2. And then we multiply by the reciprocal. So when we have a fraction, you multiply by the reciprocal. So the reciprocal of 1/2 is 2. So here I get the square root of x plus 3 equals 2. Now we're to the point where we would square both sides. And we get x plus 3 equals 4. So when we subtract 3, we get x equals 1. Number 12. All we have to do on number 12 is multiply both sides by the reciprocal to start with. And then we get x minus 1 equals 6. And we square both sides. So we get x minus 1 equals 36. And we add 1, and we get x equals 37. Any questions? All right, you guys are doing awesome. Okay, the next 6, these are all cubed roots, cubed roots, cubed roots, little roots. So watch out for that on your test. In here Wednesday and in your regular class Friday. Pay attention. Don't just assume they're all square roots or all cube roots. Watch out for the difference. All right, so when we have a cubed root, it actually is possible to take the cubed root and get a negative number. So unlike with the square roots, they can't equal a negative, these can. So I just want to make that statement before we started. The process is exactly the same though. You isolate the radical. And now this time, because it's a cubed root, instead of squaring both sides, what will we do? Cube both sides. Okay, so on your test, we're going to keep the numbers small, reasonable. So we're going to cube both sides here. and we get x minus 3. And what is 3 cubed? 27. 3 times 3 times 3. And then we add 3 to both sides, and we get x equals 30. Okay? I'm going to do number 15 with you, and then I'm going to let you finish these off. And I noticed while I was walking around, some of you got ahead of me. You already know what you're doing. So we're going to move the 3 on this one. And we get 6. And then we have to divide by the 2 so that we can completely isolate the radical. And once we've done that, then we can undo the radical. So this is the cubed root, so I have to cube. And once again, I have 3 cubes, and it's still 27. So when I add 1 to both sides, I get x equals 28. Okay, so I would like you to try 14, 16, 17, and 18. And once again, it's okay to have a negative. Negatives are okay now with cubed roots. Okay, guys. So let's go ahead and go. Alright, so we'll subtract the 3 here. And this one, I told you, it was okay to have a cubed root equal to a negative number. So this is not no solution. If this were a square root equal to a negative, it would be no solution. But we can have cube roots equal a negative number. So we cube both sides. And what happens when we raise a negative to an odd power? Does it stay negative or does it switch to positive?
Stays negative.
Stays negative. So this is negative 64. So we have x plus 2 equals negative 64. Because 4 cubed, 4 times 4 times 4 is 64. All right, so now we add, no we don't, we subtract 2 more from both sides. So then we get x equals negative 66. Okay, now this was negative, but when we divide by this negative 1, it's going to take care of that. So we get the cubed root of x plus 2 is positive 2. And then we have to cube both sides. So we get x plus 2 equals 8. And we subtract 2. And we get x equals 6. Okay? How you doing?
Horrible.
Horrible?
Horrible.
Oh no! 2 horribles? Oh my. Okay, well we'll have to practice again some tomorrow.
I don't understand what I'm doing wrong. I got both of those wrong.
Okay, I'll tell you what, I'm gonna come look at your paper in just a second, and you and I will go through it. Alright, so then on this one we subtract 3. So we get 1/2 equals a negative number. But it's okay. Cubed roots can be negative. So even when we multiply by the reciprocal, this is going to stay negative. And then when we cube both sides, it's going to stay negative. And so x, when we add 1, we get negative 7. All right, and the last one here, we add 2. And then we get the cubed root of x minus 4 equals 10. So when I cube this is going to get big. 10 cubed is 1,000, right? A 1 with 3 zeros. So we get x minus 4 equals 1,000. So when I add 4 to both sides, I get 1,004. Okay, So if you need to make any corrections on your worksheet, go ahead and do that. That's our practice solving square roots and cube roots. Now, we still have a good bit of class time left. So I went ahead and printed out the review. We were going to start tomorrow. I really like us having extra time though. When you start doing this review, it's everything. So you have to look at the function. What are the moves for this function? If it's an absolute value, I'm taking absolute values. If it's a cube, a cubic, I'm cubing. Versus a cubed root, I'm taking the cubed root. Okay? So it's all mixed up on there. And I want you to go ahead and start this. I'll let you know when you get to pack up. Let me quit recording. And then I'm going to come by and help.